Congratulations on getting to this stage, and thank you for joining our adventure. We're going to just review the system that you're building right now. We start off with the user input. You click or hold a button. These are the buttons right here. You click it, and the character starts moving. The button inputs the state direction, and there's some background processing. Just to review the code, this is the GUI. This is the GUI code, right? So this button here is that button. You type this in, the button appears. And when we alter the state, so on-click is built into the button, and we switch the direction, this doesn't actually start the movement. It's a separation of concerns. Background process, we're using async communication. It starts a thread that checks for the direction. The character moves as needed. So every 1/10 of a second, it's going to put out this string. It's just it can be any message to the queue, so the queue is not empty. And it'll happen 10 times a second. This will update the character on the screen. So this is the method function that handles the update, and we pass it the direction. So for the UI to update, which is the third step, there's an async function that checks the queue. So this one puts it to the queue, and this one will get it from the queue, put and get, and this one does not wait for something else. It's just going to grab it from the queue. If the message is anything other than blank, it will update the UI. It will briefly wait for 1/10 of a second, and you'll get this type of movement at that point. Again, we could reduce the delay to make the animation smoother, but for our purposes, it's fine. So we are separating the UI thread that handles the UI interaction, which is on the main thread, the game thread to handle the game logic. And we're using this built-in Python or library in Python called Q for safe communication. Our objective here, and there's easier ways to do this that we'll cover in the course, but so you can know the fundamentals, our objective is so that the UI does not freeze. So as the character is moving, I could make him go faster or slower while he's moving. Also, I can adjust his direction midstream while he's moving. This is due to async I/O or async communication that we're using. This is a professional code structure, and it's a scalable pattern if you separate things out. And this concept does occur in the University of California CS courses. Threads are background workers. Each thread runs independently, so you have the UI thread, the main thread, plus you have the movement thread, so that the character can move around and they communicate with each other. The queue is like a mailbox, so you drop the message into the box. As the message is there, it will take the other action. And this queue is a way to have safer data sharing between the different threads. We covered async. So this is a asynchronous function. We use the async keyword. If you actually want to pause just the thread, or just this one thread here, we use a wait. And we're using async IO, which is a package in Python that we imported at the top to sleep it on this thread for 1/10 of a second. So you'll see this type of pattern in web servers, mobile apps, data processing, and video games. Here's an example sequence at one of the UC or CSU schools. You'll learn introduction to programming with the foundation of basic concepts. In the second course, you'll be using libraries like we're using with import, state management. In the third course, you'll touch on briefly, most likely, threading and async patterns. So the UC and the CSU, they're largely lined up with industry. You are learning professional patterns. Threads, which you may not use the threads directly in a professional program, and we'll show you another abstraction layer for async IO where you don't have to use the thread, but The concept is important, so you should learn it. The thread handles the background process. The queues enable the safe communication. It's like a mailbox. You put the message from one queue in there, the other one thread in the queue, and the other thread can then grab the message. Async enables the responsive AIs, and these work all together for professional apps. The skills you gained is reading and modifying the state, creating background threads, using queues for communication, and writing async functions. The basic pattern that we're using a Python dictionary for the state. You store it, the direction, for example, in the state. It goes to a thread that is in a loop. It'll put it, if there's an update, we'll put it to the queue, and we'll use async to then get the character moving on the screen. So this pattern is quite common in professional development, and it's a foundation for advanced topics. So just to hammer it home, repetition is great. We are using a Python dictionary to handle the state. One of the properties, or the key, is the direction, and the direction has this value here, which is an enum. This is the state. The state is read in by a thread. So this handle movement is on the main thread, and it grabs the state here. So look for handle movement. We're passing it the state, the movement direction that we just grabbed, and we're telling it to move it on the screen. Although the screen at this point is not updated. So to actually update the screen, we drop it into a queue. So this is the one that does the logic on the back end to calculate the position of the character in pixels. So we do this, but we still need to update the queue. The queue is like a mailbox. We just give it a message, and we put a sleep in here so that it doesn't get too crazy. And we use this communication method here to update the UI. So we have an async function in Python. It grabs whatever is on the queue, and if there's something there, it's going to update the page, and then the character will move. Okay, you can keep practicing. You know how asynchronous movement works. It can be applied to something like talking to an LLM too, but that's the basic concept. There's basic threading, queue communication, and professional code structure. You are ready. Future lessons, we're going to dive deeper into the threading theory through repetition, learn more about async patterns, advanced queue usage, and performance optimization. Great job. You've got a working system. Modify it, change the graphics, drop it on your GitHub page. This course is designed for just constant practice and repetition. If you practice the concepts will become clearer, and these are professional skills. It also will prep you for either the UC or the CSU CS track. Have fun.